This talk is sponsored by Hedera. Run Solidity smart contracts, manage tokens, and log immutable data using hashgraph consensus to reach finality in seconds at a fraction of the cost of blockchain-based alternatives. Learn more at hedera.com.
Hello, everybody. Thanks for coming to listen to my talk. I'm going to talk to you all about maximal extractable value. This concept has been poorly misunderstood at large, I think, by the greater industry. And so I'm really excited to kind of clarify this term and why people should care about it, and what are some of the positive implications as well as some of the negative implications. So before we get into it, just a little 30-second intro on me. My name is Waylon Jepsen. I'm a graduate student at Colorado State University studying computer science. My undergraduate degree is in mathematics, and I'm doing research on modeling discrete event systems with tropical algebra and consensus stability in distributed ledgers. And part-time, I work doing developer advocacy with Hedera, where I help people learn how to use the Hedera services. So let's see if I can get to the next slide. So the goals for this talk are going to kind of introduce MEV and see what sort of constraints we can define MEV within, and then talk about why MEV is important, talk about which platforms are affected by MEV. There's a lot of ambiguity, I think, here. And then I'm going to present some of the open research questions. And I'm actually collaborating on a bunch of these research questions with my university. But if you're interested in any of these research questions, definitely feel free to reach out to me. There's a wonderful community of people in industry and also at academia that are working on some of these problems, and we are always needing more bright minds to look into some of these open questions. So what is MEV? So I think one of the reasons MEV is kind of misunderstood is because its acronym actually changed halfway through. It used to mean minor extractable value, and then it was changed to maximal extractable value to encompass larger financial systems. So this is a very encompassing term. MEV does encompass a lot of different activity. But more generally, it's classified as any value that can be extracted by transaction ordering mechanisms. So in the last year on the Ethereum network, there's been about $800 million in USD extracted in MEV in the past 2 years. And so this is a lot of money. You've probably heard of a lot of people that like quit their jobs to go look for MEV and try and extract MEV from different distributed ledgers. This has kind of been a really big honeypot for a lot of engineering talent or those just inclined to learn. And I think this has actually been really good because a lot of people are now financially very incentivized to learn about how to write smart contracts and learn about using the Ethereum virtual machine and how to interact with different opcodes. And I think that has been good. There's been a lot of people that have cultivated a lot more deeper understanding of the technical tools in our industry because of this, which is an overall positive thing. So here's a little bit of well-known types of MEV. So if you're familiar with decentralized financial protocols, lending protocols allow you to deposit collateral and borrow against this collateral. One of the most popular lending protocols being Aave. However, there are others like Rari Capital, My Finance, and they all vary a little bit in kind of their design. But one thing they need to ensure is that these loans never become under collateralized, right? Because if you have a default loan, that's a big risk. You know, this is what happened in the 2008 financial prices. So to ensure that their protocols are sustainable, they actually incentivize other people with rewards to recollateralize under-collateralized positions. And this is called liquidating. And as a result, people can make good money liquidating under-collateralized positions. And this is a type of way that you can extract value through different transaction ordering. And so liquidating people is actually quite competitive, and most of this is all done through automated processes. People build bots to do all these things and try to optimize these bots so that they do them faster and they compete with each other. And we'll get into some of the game theory of that competition in a couple slides. So liquidations are overall really important. Of course, it's not a good thing to the person that got liquidated because it's at a cost to the person that got liquidated, but the liquidator does receive money. And, regardless of, how you feel, you don't want to get liquidated. Nobody wants to get liquidated, but you can totally mitigate your risk in volatile markets. Like, if you have enough bandwidth, you can be pretty diligent about not getting liquidated. It's generally people that are careless, but also big market fluctuations do sometimes happen in this industry. But it's very important that these loans remain over collateralized. So liquidations are overall a really important thing, negatively impacting the person that becomes under collateralized and positively impacting the liquidator. So another type of MEV is pretty well known is front running. Front running is basically the act of viewing transactions in the public mempool and seeing ones that you could copy and pay a higher gas for and receive the profit that would be the result of that existing transaction. So I think one of the first examples was the birthing of CryptoKitties, where the birthing transaction of a new kitty had a unique hash where if submitted to the right contract, it would return a kitten, a new CryptoKitty, right? And so people would see this and they would front run these kitties by copying this transaction with the unique hash, so they actually got the kitten. And the people who actually birthed the cats and put in the work on the different fertility time clocks that have to do with CryptoKitties didn't actually receive the cat. And so these users, of course, were upset about this. Nowadays, there's some mechanisms in place that you can use in your development processes to stop things like this from happening. Another type of MEV is arbitrage. So arbitrage is defined as capitalizing on price discrepancies in different markets and market inefficiencies. So if an asset is sold at a high price here and a low price there, you can buy at this high price and sell at this low price. Usually these are on two different decentralized exchanges. However, there is arbitrage across centralized exchanges and decentralized exchanges, and even across multi-chains. And arbitrage is widely considered a very good thing and actually quite necessary for financial markets to be efficient. And the reason for this is they drive a price equilibrium, which is always going to give the end users the best price for their assets. Another type of MEV is a sandwich attack. So a sandwich attack is where you sandwich a user's transaction between two transactions, usually leveraged with, say, a flash loan with a large amount of volume of an asset, so that the price of an asset either inflates or deflates before and after, and then you capitalize on the discrepancy here. And this has a negative impact on the users that are sandwiched. And actually, this is probably one of the types of MEV that is most looked down upon, because it's just kind of mean. It's kind of at the consequence of the user, where the user is getting the worst possible price for their trade. And I actually don't know very many searchers that actively orchestrate sandwich attacks. I think in the searching community, searchers are people that look for MEV and capture MEV. Most of them do have some ethical bounds, and are not like always looking to sandwich attack. And then there's a very, very long tail of niche MEV, and you can imagine you can be incredibly creative and find ways to extract values from different blockchains. And so this is kind of where a lot of people like try and figure out different ways to do this. There's stuff that people do with index tokens. There's cross-chain MEV. So these are some of the well-known types of MEV. So hopefully you have heard of some of those, and maybe now you have a better perspective on those. So when these bots called searchers, the people looking and searching to capture and extract MEV, compete with each other, there's a game theoretic model that's played. It's played by the searchers and the validators. This is particularly in the Ethereum blockchain, right? And so the miners on the Ethereum blockchain, they're responsible right now for ordering transactions. And, they do so in the order that is most profitable to them. So they will order them into the degrees of how much gas fees have been paid for this transaction. If one has been paid with a very high amount of gas fees, they'll put that one at the top because the miner makes the most money from processing that transaction. And they want to make the most money from processing the block as possible. Now, the searchers express these ordering preferences with the transaction fees, but they actually compete with each other, and so they result in bidding wars. So some searchers maybe identify the same MEV opportunity, and they compete by increasing the fee for this transaction so that they'll get it with other searchers. And this is actually called a priority gas auction, where these searchers kind of try to outbid each other. And this happens until the auction is either won or is no longer profitable. There's actually a really amazing paper if you're kind of interested in MEV. Is kind of the first paper published in an academic journal on this sort of phenomena in distributed ledgers. It's called the Flashbots 2.0. And in this paper, they actually illustrate a Nash equilibrium for these priority gas auctions. But let's go next. So next, why is MEV important? So the big, of course, there's different parties that are affected, right? If you use decentralized financial protocols, you want to be aware of maybe it is possible that my transaction could be front run, or I know what a sandwich attack is and what the risks are there and what makes me most vulnerable and maybe how to avoid that. So it's good to know those things, and that's one reason why you should care. But I think the primary reason that a lot of people care and why Vitalik has actually been active in the MEV community is because there is a potential valid attack on the consensus stability of Ethereum. So if you aren't super familiar with the way Ethereum it uses probabilistic consensus. So that means after a certain period of time, there's a high degree of likelihood that your transaction is final, right? This is why you wait for a certain amount of block confirmations after you submit a transaction before your transaction is perceived as valid. However, if an entity were to identify a block in the past, not short amount in the past where you have like uncle blocks and a lot of ambiguity of the longest chain, and that's why you wait a certain time to find the longest chain to develop. But a block kind of far in the past, like maybe say like 15 blocks in the past, maybe longer even, right? And somebody identifies that if they were to order the transactions in that block differently and maybe include different transactions than the ones that were included in that block, they would make an incredibly large amount of MEV. So if somebody does this, and if that value, that monetary dollar amount of that value that they could extract is greater than the cost of resources to go back to that block and mine a new longest chain from that block, this would be a valid attack on the consensus stability of Ethereum, right? Somebody would basically go back in time and create a new longest chain from this block. And you're like, well, that sounds like that would be really ridiculous, right? Like it takes a very large amount of computational resources to make a longest chain. And, this fact has kept Ethereum quite secure for some time. However, it was actually shown in the Flashbots 2.0 paper that with empirical evidence that this is actually a valid attack. And there actually is that large of quantity of MEV to be extracted from blocks. And so not only is this people financially incentivized to orchestrate this attack, but there's enough financial incentives here to cover the cost of orchestrating this attack as well. And so this is kind of the primary concern. This is what everybody doesn't want to happen. We don't want this to negatively affect Ethereum's consensus stability. Another reason why you should care is because some other negative externalities here are censorship and collusion, right? Like we really want distributed ledgers and Ethereum to be open public networks that are transparent and available for anybody to use, right? Well, you can imagine that maybe if bot searchers compete so aggressively, they create kind of a state bloat and they drive up the gas prices for regular users, making gas prices really high for regular users. There's also, one can imagine that you can derive a cost of censorship, right? Like how much money would you have to pay in transaction fees and individual transactions to have all of the block space to yourself and not let anybody else have any of this block space. These are kind of the questions and problems that make MEV really relevant and are some of the problems that people want to mitigate. So let's take a look about what is Flashbots. So Flashbots is actually a research and development organization that's sole purpose is to mitigate these negative externalities of MEV. So they aim to bring transparency to MEV activity, democratize access to MEV, so reduce the barrier to entry, and enable fair distribution of MEV revenue. Now, these are kind of ambitious goals, but I think they are very noble values. And I actually quite admire the Flashbots organization and think they do a lot of really, really great work. So the first product that Flashbots actually released is something called Flashbot bundles. And what the Flashbot bundles are is they allow people to group transactions together where they are executed deterministically. So you won't have half of your transactions executed. You will just have either your entire bundle executed or not. And this reduces some barrier to entry because this way the profit of the entire bundle is evaluated rather than the individual transactions. So you can actually start the transactions in your bundle and not pay anything for those transactions if overall the final execution of all of your transactions does result in profit. So this reduces maybe some startup capital that might have previously been necessary for transaction fees, not a lot for searchers or people to start searching. But another thing, and probably the more important thing that Flashbot bundles does, is it actually migrates the priority gas auctions off chain. So the Flashbot bundles are actually submitted via a private relay to miners that run a modified Geth client called MEV Geth. It just allows the miners to accept Flashbot bundles. And this is good for two reasons. It actually reduces state bloat of the chain, and it actually doesn't universally increase the gas fees for all the other users as the result of these auctions, which is really nice. So this way, users aren't negatively impacted by these priority gas auctions, these kind of aggressive bidding wars between searchers, and users can still have, maybe a little more reasonable transaction gas fee. So bundles produce some user transaction privacy, which is also interesting. These transactions don't actually go through the mempool. So if you've been following Flashbots, you know that some decentralized exchanges actually started using this as a way to protect users' transactions from getting potentially front run or sandwiched. So this is another application of using Flashbot bundles. And I think the way they do this is they call this product, when they use Flashbot bundles this way, they call this Flashbots Protect. So Flashbots works in these three areas of auction design, data, and research. So next I'm going to kind of summarize some open research questions here, and then I'll wrap things up. I don't want to go too far over time. If you do have more questions about this or want me to clarify anything that I've talked about, feel free to DM me on Twitter. My handle is 0xjepsen, that's Jepsen. And I'll do my best to also make these slides openly available to people and any other resources that I have and can provide as well. So let's dive into some of these research questions. I'm probably going to go pretty quickly over these. One research question is auction design. Do we know if the priority gas auction is the best auction design for these searchers to compete their bundles with? Maybe, maybe not. Should we provide additional crypto economic incentives in these auctions? And what should these auctions demand from all of the participating actors? So there's a lot of need for people to do analysis and objectively study different auction mechanism properties to identify what the best auction design for these searchers to participate in would be. Cryptographic privacy is also another issue here. So currently, when you submit a bundle to a miner running MEV Geth, and by the way, more than 50% of miners run MEV Geth right now. So there's been a huge adoption by the validators in the Ethereum network of the MEV Geth client. This is very ubiquitous, and they're financially incentivized to do so, right? But miners currently do have the ability to unwrap a bundle and look at transactions and accept and take all of that value for themselves and giving none to the searcher. Now, one could argue there is a little bit of crypto economic incentive in place in the sense that identifying MEV opportunities is challenging, and the miners wouldn't want to jeopardize the relationship they have with searchers, where the searchers identify the MEV and then give the miners a cut for helping them capture the MEV through transaction fees or tips. One can think of them as like bribes as well. So there's some work to be thought about on enabling privacy of searchers, like these searcher miner privacy. There's been some initial work done here with the use of secure hardware enclaves. Although hardware enclaves are kind of controversial, you have to depend on proprietary hardware, and this is generally not something that's preferable to cypherpunks and people that care about privacy, and they don't like depending on proprietary hardware. However, this is a hard problem. The question here is, can we apply different cryptographic primitives to ensure this privacy guarantee? And then same problem, but should we use economic incentives and define different incentive mechanisms to preserve this privacy? Another open research question is, we all know that Ethereum is planning to migrate, and I know it's no longer called ETH2, but it will be migrating to proof of stake. And the question here is, what does MEV look like in this evolution of Ethereum? And there has been some work done here, but basically the questions here is like, we don't want to create kind of this economic gravity, this centralizing force, right? We want things to be fair for all validators. And actually, I think some of the most recent work Vitalik has been participating is there's this work in separating the entity that orders transactions and the entity that validates transactions in this block proposal model. And this helps mitigate some of the concern around the consensus stability problems here. But there's some resources here, and there's some at the end of the slides as well on this research question. Also, another open research question is, what does MEV look like in layer 2 protocols? What sort of transaction sequencer mechanisms to protocols like Polygon, Arbitrum, Optimism, Starkware, what do they use? And whatever they use, how does that affect the capture of MEV? I know there has been some evidence and searchers that have captured MEV in Polygon. MEV is widely to be considered very ubiquitous and not something you can actually ever get rid of. And actually, there is a ton of MEV in traditional financial systems as well. This is what high frequency traders capture when they make money. In fact, there's a whole book on it. It's called Flashbots, A Wall Street Revolt. And if you're interested in MEV in traditional finance, I recommend that book as well. But it is a naive thing to do to claim that there is no MEV in a protocol. I've seen a lot of people claim this, and it's kind of silly because you actually do want some MEV, like you do want arbitrage, right? You want your markets to be efficient. But there are good kinds and bad kinds of MEV. I think what a lot of people often conflate is they confuse MEV for just front running. And that's not quite accurate. So then there's taxonomy, and there's been a paper called Clockwork Finance that has done some initial work on this, additionally with the other paper, Unity is Strength. But the idea here is we want to build a robust theoretical framework for quantifying and analyzing different aspects of MEV. There is account abstraction. So actually, Vitalik suggested you could use Flashbots as account abstraction. Account abstraction is the idea that transactions don't originate from an externally owned account requiring an elliptic curve digital signature, but instead they can originate from like maybe smart contracts. So some applications here are like smart contract wallets, like Gnosis Safe, where these are multi-sig wallets. There are some cryptography research questions here around distributed key generation and arbitrarily weighted signatures that are all cool research questions to get into if you're really into math and cryptography. And work here could have impact and maybe better social recovery wallets. I think there's a lot of engineering work to be done here on making kind of things like social recovery wallets more user-friendly and accessible and easy to use. Protocol design is another big research question here. This is basically investigating the design principles of consensus protocols, but also the design principles of different DeFi primitives, like decentralized exchanges. Like, how do these constant function automated market makers or bonding curves or different concentrated liquidity provisioning models impact MEV, right? There's a pretty cool project out here called Primitive Finance, in which they are actually not using oracles. They're actually using their CFAMMs as price oracles. And this is similar to Uniswap V2, but one thing they do is they have different concentrated liquidity strategies that are allowing people to do rather than just one XY equals K liquidity curve like Uni V2, which is beautifully simple and not very computationally demanding, but the cost there is that the users are subject to slippage, which does have an impact on MEV. So these are some of the research questions here, like how do we design protocols with this in mind to build a better quality of service for users. Search optimization. A lot of searchers that are looking for MEV have actually done amazing work in this. However, most of it is kind of a trade secret, right? Because if they were to leak how they're optimizing their bots to be faster and do better searching, they would be basically giving up their competitive edge against other bots. But there's a lot of opportunity to do work in search optimization in this domain as well. I'll skip over this one just because I want to be able to be done by 30 minutes, keep things pretty concise. Of course, MEV and other protocols is an open research question. Do deep reorgs happen in other protocols? Is that a valid consensus stability concern? And if not, what are the dominant MEV strategies in other protocols? There's been evidence of searchers in some other protocols doing quite well financially. So what does that look like? How can we democratize and bring transparency to this activity? And then that's about wrapping it up. If you have any questions on this, definitely feel free to reach out to me. I know I put a lot of information on this slide, and I know not all of the topics here are trivial, but always happy to talk more about this. And I'm actually working on some papers through my university on this, so would love to talk to people about MEV.